Okay, in this problem, we are given a graph only. We are not given an equation to work with, so we are entirely answering all of these questions just from the graph. When we're given an equation, as we're going to be given an equation in number 6, that's when we go to our calculators. But here, there's no equation, so we're going to answer every single one of these 5 questions just using the graph. The graph below shows the height of a baseball. So height is going to be in meters. So it's going to be along the y-axis from the time it is thrown from the top of a building to the time it hits the ground. So the graph shows the height of a baseball from the time it's thrown from the top of a building. So you're not standing on the ground throwing the ball. You're on the top of a building throwing the ball up. It's going to go up. It's going to hit a maximum. It's going to reach a maximum, and then gravity is going to bring it all the way back down to the ground. So if I am standing right here, let's just say that's maybe me standing on top of a building and I throw the ball up. The ball is going to go up. I'm going to watch it go up. I'm going to be looking up in the air. Then I'm going to watch it come down, and my eyes and my head are going to have to look downward to see the ball hitting the ground, hopefully not hitting someone, because that would be very painful. How much time elapses while the ball is 80 meters or more above the ground? Right here, it looks like 10, 20, 30, 40, 50, somewhere between 40 and 50. I would say about 45 meters high is where we throw the ball up, and we want to know how long is it above 80 meters off the ground. So here's 80 meters right there. So how long is it 80 meters or higher? Well, from 1 second to 7 seconds, that's a difference of 6 seconds. Okay, next question says, when does it reach its highest point? Its highest point is right here. The word when means time. When does it reach that highest point? That looks like it's about 4 seconds. How long has the ball been in the air when it hits the ground? Okay, here's the ball hitting the ground right here. That's at 9. It wasn't in the air yet until I throw it up. So from 0 seconds, then it goes into the air. At 9 seconds, it lands, and the whole problem is over. So that lasted for 9 seconds. Throwing the ball up in the air, watching it go up and then fall down to the ground took a total of 9 seconds. Now, about how tall is the building from which the ball was thrown? That was somewhere between 40 and 50. I'm going to say 45, and it was in meters. About 45 meters. How can we tell from the graph that the ball was thrown and not just dropped? Well, the fact that it went up in the air tells us that the ball was thrown. If we just dropped it, it would just fall. So it would just fall down, and it would fall like this. So it would fall like that. Now, that doesn't mean it's being thrown out. So that's not the path it takes. It's just going to fall, boom, and it's going to hit the ground. So it's not going to fall as quickly at first, but it's going to fall faster right about here, and then boom, the longer it's falling, the faster it's going to fall. How can we tell that the graph was thrown? I would say that explanation was the ball first. Let's just say the ball goes up first. And that's how you evaluate and answer some questions just with respect to a graph. And this type of questioning is the type of questioning that you see related to a graph on certain standardized tests. On certain standardized tests, they'll just give you a graph and ask you to evaluate and ask you certain questions like that. So next question, we will be working with our calculators. So the next question in our videos, we will be working with our calculators.